Welcome to this video on variables and constants in programming. In this series on computer world terminologies and concepts, we'll explore how programs store and manage data. Variables and constants are fundamental building blocks that every programmer needs to understand. They allow us to store information, manipulate it, and use it throughout our programs. Let's dive in and learn what makes them different and why both are important. A variable is a named location in memory that stores data. The key characteristic of a variable is that its value can change during program execution. You can assign a new value to a variable as many times as you need. On the other hand, a constant is also a named location that stores data, but once you assign a value to it, that value cannot be changed. Constants are immutable, meaning they stay the same throughout the entire program execution. Let's look at the key differences between variables and constants. Variables allow you to reassign and modify their values as your program runs. This flexibility makes them perfect for data that changes. Constants, once assigned, remain fixed and cannot be modified. This immutability prevents accidental changes to critical values. Both variables and constants occupy memory locations in your computer's RAM. By convention, constants are often written in uppercase letters. This naming practice helps developers quickly identify which values should not be changed. Let's see how to create variables in Python. Here we're declaring three variables: name, age, and score, and assigning them initial values. Name is assigned the string Alice, age is assigned 25, and score is assigned 92.5. The beauty of variables is that we can reassign them. Later in the program, we can change age to 26 and score to 95.0. Python doesn't require you to declare the type of variable beforehand. It automatically determines the type based on the value you assign. Now let's look at constants in Python. By convention, constants are declared using uppercase letters. Here we have pi set to 3.14159, max users set to 100, and gravity set to 9.8. Importantly, Python doesn't enforce constants at the language level like some other programming languages do. It relies on programmer discipline and convention. If you try to change a constant value, Python won't stop you, but it's considered bad practice. The uppercase naming convention is a signal to other programmers that these values should not be modified. JavaScript has a built-in way to enforce constants using the const keyword. Here we declare pi, max attempts, and database URL using const. When you use const in JavaScript, the language actually prevents you from reassigning the value. If you try to reassign pi or any other constant declared with const, JavaScript will throw a type error. This is much stronger than Python's convention-based approach. The const keyword gives you the protection of true immutability. This makes JavaScript constants more reliable for protecting critical values in your code. Variables and constants serve several important purposes. First, they allow you to store data during program execution, holding values that your program needs to work with. Second, using named variables makes your code more readable and self-documenting. Instead of using the number 3.14159 throughout your code, you use the name pi, which is much clearer. Third, constants provide data protection by preventing accidental modifications to important values. Finally, both variables and constants promote reusability. You can use the same named value multiple times throughout your program, and if you need to change it, you only change it in one place. Let's summarize what we've learned. Variables store data that can change during program execution. Constants store data that remains fixed throughout the program. When you're writing code, use variables for dynamic data that changes, and use constants for fixed configuration values that should never change. Understanding when and how to use variables and constants properly is essential for writing clean, maintainable, and bug-free code. This knowledge forms the foundation for all programming languages and concepts you'll learn in the future.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.